Hi guys, welcome to the Logic Tree Institute. So today we are starting with the revisionary notes for the 8th reading of your curriculum, or it is also the 3rd chapter from your quantitative methods subject, that is statistical concepts and market returns. So first of all guys, this is a revisionary notes, so we will be taking it forward very quickly. So these are the contents of the chapters. So we will start with introduction, then after that we will go with the fundamental concepts. Then after that we will be summarizing data using the frequency distribution. So here we have the topics like histograms and all that. After that we will do the measures of central tendency and measures of central locations as quartiles, quantiles and percentiles. After that we will do the measures of dispersion, and after it we will learn the basics of skewness and kurtosis in the returns distributions. So let's begin with the stats. So there are basically two types of statistics. First is the descriptive statistics and second is the statistical inference. So descriptive statistics is all about like we are making deductions of the data or from the data. So we will be having a data set. Let's say we have a 7%, 8%, 9%, 3%, 2%. So these are the returns of 5 stocks, let's say in last 1 year. And now I want to induce what I can indicate, what does this data indicates to me. So there are basically includes the measures of central tendency, that is mean, median, mode. Then we have measures of location. Then we have about the skewness and kurtosis. And lastly we have the measures of dispersion, that is variance, standard deviation. So all these things we will cover in this chapter. So primarily we are focusing on descriptive statistics in this chapter, and the later readings in the curriculum deals with the statistical inference. So the statistical inference is all about making forecast from the data. So you are inferring what the data is saying to you. So this deals about how is the data, what is the type of the data, how the data can be used. Next is all deals about how we can use to make forecast from this data. So the first we start with sampling. Now consider I want to, like in India there are millions of schools. So now I want to find the average score obtained by the students in 12th class in all the schools located in India. So there will be around thousands of schools and there will be around millions of students who are passing their 12th. So I want to find what is the average score obtained by the students in class 12th. So this indicates my population. That is, it is my entire universe. Now here I am considering whole of India, so it will be very tough for me to find the average of the average of scores marked by the students in class 12th. So that will be very difficult, very costly, very time consuming for me. So what I can do is, let's say from each state of India I take a randomly 2 schools. Assuming there are 28 states, I will multiply it 2, so I will be dealing only with 56 schools. So now this is far less time consuming as compared to the previous one. So now I have to, this process is kind of replicating the average score what we have to find of population. Yes, it will not be accurate, but it will be around, or you can say comparable. So in this case, when I have taken only 56 schools of the total schools, I have taken a what? A sample. So sample is simply a subset of population. Now using sampling, my accuracy will decrease. Definitely it will decrease. But I will gain in terms of time consumption and the major thing, that is cost. So there will be benefit in terms of time consumption and cost, but on the other hand, I will lose in terms of accuracy. But still, a sample will, I would say, not completely, but yeah, it will be at a sufficient level. It will be describing or acting like a population for me. So when I am finding any statistic or characteristic of population, like here what we are finding was average of population. If I find mode median of population, so if I am dealing with any characteristic of population, it is known as parameter. While on the other hand, when I will be dealing with the characteristics of the sample, then it is known as sample statistic. Guys, this topic is not important from the testability perspective, but you guys should be aware of these concepts. So that is important from concept perspective only. Moving forward, now we have measurement scales. Now there are 4 types of measurement scales. First is the nominal scale. Let's say I want to categorize the stocks listed on National Stock Exchange India. Now I want to categorize these stocks primarily in 3 categories. Let's say large cap, mid cap, small cap. So I have categorized them on the basis of market cap. So when I am dealing only with categorization, that scale is known as nominal scale. So nominal scale primarily depends or works only for categorization. Now, next comes the ordinal scale. So in ordinal scale, I can categorize as well as rank them. A very common example is, let's say there are 3 people, A, B and C. They started the race and A completed the race in, let's say, 50 seconds, while B completed the race in 52 seconds. Like C completed the race in 55 seconds. So A stood the first, while B stood the second. So I can, if I give a rank to this, so A scored a rank of first, B scored a rank of second, and C scored a rank of third. So now in this case, I have categorized the person on the basis of ranks. So the first property I have done is categorization. The second property is, if I say A is first, so that means A reached the final before B, B reached the final before C. So here in this case, I have categorized as well as does the ranking. Now next comes the interval scale. Interval scale, this is not primarily used in finance. You will not find very much examples of interval scale in finance. Now, interval scale, classic example is temperature. Now it says it has the property of categorization, ranking, as well as intervals. Let's say I have a temperature of 19 degrees Celsius and 20 degrees Celsius. So now difference between them is 1 degree Celsius. Similarly, the difference between 1 degree Celsius and 2 degree Celsius is 1 degree. So when I compare between the two, the interval is always the same. While in the ordinal scale, if we compare, if A is greater than B and B is greater than C, I can't say that the difference between the timings the A and B have is similar as B and C, as the difference between B and C. So like in this case, in A and B, I have the difference of 2 seconds. While in case of B and C, I have the difference of 3 seconds. While on the other hand, in the interval scale, the difference between the two numbers is constant. But here, I don't have any reference point. So now to measure the temperature, we generally consider 0 degree Celsius as the reference point. But no, 0 degree Celsius is freezing point of water. It doesn't mean absence of heat. So even in terms of kelvins, if we say minus 270 degree kelvins is assumed to be the lowest point, but this is the point which we humans are able to measure. Below this, we are still not able to measure that on the scale. But that doesn't mean that here below this point the heat is 0. That doesn't mean that. So we don't have any reference points in case of interval scale. Another common example is IQ. When we measure the IQ. So a person with the 0 IQ doesn't mean he doesn't have any intelligence. Still he is able to manage his work. He is able to function as a not on the intelligence scale, but still he is able to manage his daily work. So he is having a few kind of intelligence. So an IQ of 0 doesn't mean a person has no intelligence. Now next is the ratio scale. Ratio scale consists of all the properties of above, that is categorization, ranking, interval, and it also has a reference point. So if I say a stock generated a return of 0%, so it simply means a stock has reported 0 profit. So a 0 means 0. So that is a simple concept you guys can revise. Guys, this is one of the important topics. This is important, and it is important from the testability perspective. You can expect a question, while it is not a sure shot, but still you can expect a question on the basis of scales in exam. Let's come up with the next topic, that is the frequency distributions. Now frequency distribution is simply defined as a tabular display of data summarization. Let's say I have a stock returns of 5 stocks as 7%, 8%, 9%, 3% minus 10%. Now I want to categorize them. Let's consider it to be plus 10. Now what I can do is, to summarize this, I can make the intervals. Let's say first interval is for any returns that are below 3%. Now next is 3% to 5%. So below 3% I have 0 number of stocks. Between 3 and 5 I have a 1 stock. Let next interval is 5 to 7. In this case we are assuming that is less than the right upper side, that is less than the number is less than the upper side of the interval. So it will be less than 5. Similarly, in this case it will be less than 7. So between 5 to 7 I have 0 stocks. Next is 7 to 9%. In 7 to 9 I have 7% and 8%. So I have 2 stocks. Between 9 to 11% I have 9% and 10%, that is 2 stocks again. So representing my data or summarizing my data in terms of interval is known as frequency distribution. Now absolute frequency is the number of times the stock has repeated in this interval. So in this case 1 is the absolute frequency for the interval 3% to 5%, while it is 0 for the intervals less than 3%. Next comes with the concept of relative frequency. Relative frequency, it is with respect to total number of observations. So in this case I have total number of observations of 5. So the relative frequency of 3 to 5% interval is 1 upon 5, or I would say 20%. While for 7% to 9% it is 2 upon 5 equal to 40%. Similarly for 9 to 11% is 40%. Now if I cumulate them or sum them, so if I sum them, that is known as cumulative relative frequency. Let's say for the stocks less than 3% it is 0, then less than 5% it is 0 plus 1, so that comes to be 1, or I would say in terms of relative frequency it is 20%. And next for the stocks less than 7% I have again 20% of my observations are. For less than 9% I have around 60% of observations. For the interval less than 11% I have a cumulative 100% of observations. So 100% of observations lie less than 11%. So this is the concept of the absolute frequency, relative frequency and cumulative relative frequency. Guys, this is not so much important for the examination point of view, so please don't spend much time on this.